Here I'm going to discuss a question from the chapter circle based on the concept of tangents. There are concepts related to the tangents of a triangle, and based on that we need to solve this question. Let me read this question first. The two tangents TP and TQ are drawn to a circle with center O from an external point T. Okay, so we have here external point T. All right, this is our external point T. From this external point T, we are drawing two tangents TP and TQ to a circle whose center is O. Okay, and now further the question is saying prove that PTQ equals to twice of OPQ. PTQ, okay, PTQ means we need to prove that this angle is twice of this one. All right, OPQ. Yeah, they're saying that if this is x degree, then this must be twice of x degree. All right, I mean, according to them, if this is 30 degree, then this must be 60 degree. If this is 45, this should be 90. If this is whatever, just double of that it should be. We need to prove that. So before solving this, let's check it out. What exactly we need to prove? We need to prove PTQ means our angle is this one and this one. These two are related. All right, and okay, so before that, let me take you to something. I want to tell you something about the tangents. All right, first, if you don't know about the tangents, let me tell you what is tangent. This is a circle. All right, tangent is that line, which is just touching one point of that circle. It's just one point it is touching. All right, so that time this is called tangent of the circle. All right, and this point is called point of contact. And in the tangent, if you connect that with the center, I mean, if you connect with the radius, this is actually radius, this will work as a radius, then the radius will be perpendicular to the tangent always. Keep in mind that always, it's a theorem. All right, radius will be always perpendicular to the tangent at the point of contact. So this is 90 degree. This was little about the tangents. And one more concept you need to understand. You have a circle, let's say, and from an external point, if you're drawing a tangent to the circle, if you're drawing tangents, all right, tangents, keep in mind, plural I'm talking. So how many possible tangents are there to draw? There is only two possible tangents. Tangents means just touching a point, so this is one, and if you draw like this, it's not going to be tangent. Tangent is just a point it is touching, so there is only one possible more tangent. So these are the two tangents possible if you're going to draw from an external point. So keep in mind, from an external point you can just draw two tangents, and both tangents are equal. Keep in mind. All right, both tangents are equal. I'm going to say this distance from this point of contact to here, this distance, and from this point of contact to here, both are equal. All right, this is equal with this part, always and always. Keep in mind that. All right, and if these two are equal, then if you connect these two point of contact, then you are going to have an isosceles triangle, because the two sides are equal. And if the two sides are equal, definitely their corresponding angles will be also equal. This angle and this angle will be equal. All right, so this was a little brief about the tangents. And if you have these two concept of this and concept of this, you can easily solve this question. All right, let's take a look once. So here tangents TP and TQ are drawn to a circle with a center O from an external point T. So as I told you, from an external point you can just draw the two tangents, and the both tangent must be equal. So here TP, I'm going to say this TP and TQ are equal. So this TP and TQ are equal. So if this TP and TQ are equal, then definitely I told you, if you join these two point of contacts, then you can get a isosceles triangle. So it means TPQ is an isosceles triangle. All right, so therefore this angle and this angle should be also equal, because this is equal, so corresponding angle is this is equal, so corresponding angle is this. So corresponding angles are also equal in isosceles triangle. All right, this is what the concept I used here. So one by one I'm going to write everything. All right, here first I will write TP equals to TQ, and the reason of this is tangents drawn from an external point to a circles are equal. All right, are equal. Okay, and if TP equals to TQ, therefore I can easily write triangle TPQ. All right, this is TPQ is an isosceles triangle, and the reason for this, you can give TP is equals to TQ. And now the next one, what you can write, again you can say that angle TPQ is equal with angle TQP, and the reason for this, TPQ is an isosceles triangle simply. That's it. Okay, now we need to prove PTQ equals to OPQ. So what kind of relationship we can draw between these two things, this angle and this angle? Okay, so if these two are equal, okay, yeah, one thing is here, in a triangle, in triangle TPQ, all right, angle PTQ plus angle TPQ plus angle TQP equals to 180. I'm sure you're 100% agree with me in this case, because the sum of the internal angles of a triangle is always 180 degrees. So sum of this angle, and this angle is 180 degree, because sum of internal angles of a triangle is 180 degree. 180 degree. All right. So further, see what I'm going to do here. See, the question is asking me, we need to prove PTQ in the terms of OPQ. See, we have here TPQ, PTQ, all right, PTQ we have here, that's fine, and we need to remove these two things. Means these two angles are equal, so I can easily convert both angles are equal, so I can write angle TQP in terms of TPQ, this angle in terms of this, and when I will write everything in terms of this, I can easily convert into the angle OPQ form, and we can easily get the relationship. All right, so first, now I'm going to write TQP, this TQP in terms of angle TPQ, because I'm getting very closer to the OPQ. Final, our destination is OPQ, OPQ is here, so I'm just writing this thing in terms of this. Okay, we're getting closer and closer. So it's PTQ plus, now this is TPQ as it is. All right, let's write TPQ plus, again I am writing this is TPQ equals to 180 degree, and the reason for this is both angles are already equal, we have already written, right? Angle TPQ is equal with angle TQP. Okay, further, now you can write angle PTQ equals to 180 degree minus C. 2PQ both will go on another side, so it will be twice of, I'm not going to step. All right, so it's TPQ, it's twice of TPQ, all right, equals to 180 degree. You can jump the step, all right, but if you'll get confused, that's what I'm trying to write each and every step. It should not be so much longer, it's very short. All right, angle PTQ, now I can write 180 degree minus twice of angle TP and Q. All right, I just took this into the another side. That's it. Okay, so now we need to do a little magic here. We need to convert this TPQ in terms of the things that we need, OPQ. All right, so see here, we have written our TPQ here angle. All right, this is TPQ. Now we need to write this angle TPQ in terms of OPQ. So how can we do this? So it is like this, it is something like this. All right, and here we are given this angle, so can't I write this TPQ, as a whole this angle minus this angle? All right, I mean to say angle TPO minus angle OPQ is actually TPQ. All right, so I'm changing that. All right, it's 180 degree minus, now see, I'm going to change this TPQ as this TPQ as a whole TPO minus OPQ. All right, so that's giving me angle TPO minus angle OPQ. All right, and it's PTQ. All right, so let's write for the PTQ equals to, now this is 180 degree minus twice of TPO. So what's the value of TPO? Recently what I told you, this is a point of contact, and this is a tangent, and if you connect from the center, the radius it is, so radius is always perpendicular to the tangent, so it means the whole angle is 90 degree. This whole angle is 90 degree, just here I think I told you here. All right, see, this is a point of contact, this is a tangent, and this is the radius. So radius is always perpendicular to the tangent, and in our question it is something like this. All right, so this whole thing is 90 degree. Okay, so I can write this was our T, this was our P, this was our O. So angle TPO is definitely 90 degree, because in our case it is something like this, you know. In our case it is something like this. The point of contact is here. All right, it's T, it's P, and it's center here O, and another line is here Q. All right, and this is another point of contact. So this whole thing must be 90 degree, you know. This is a tangent, you know, and the radius must be here perpendicular. So angle TPO, this is 90 degree, so that's what I'm going to replace it here. So this TPO is 90 degree minus angle OPQ. Okay, and we are now very close. Angle PTQ equals to now 180 degree minus 2 times 90 degree, that is 180 degree, minus times minus, that's plus 2 angle OPQ. This 180 cancel up, and angle PTQ equals to twice of OPQ, and this is what you need to prove it. All right, PTQ equals to twice of OPQ. PTQ equals to twice of OPQ. Here it is. All right, very simple. You just have to use the two concepts that I told you. The radius is always perpendicular to the tangent, and from an external point, if you draw the tangents, then only you can draw the two. There is only two possible tangents, and both tangents are equal. All right, I hope you understand this, and if there is any confusion or any doubts in this question, in this explanation, then please feel free to comment below this video. I'll be very happy to reply you. Goodbye, and don't forget to subscribe the channel.